All right, so here's the answers to the review sheet. You will notice that I will not be using Desmos or anything like that, so no Desmos on your test. You can use the calculators that we have in class here if you really need to, but you kind of don't need them. Anyway, here we go. So on this first problem, I want h of f of x. So it means that h is the boss, and I have to plug in f of x into that. So I'm going to get 3 something squared minus 2 something here. So inside that parentheses, I'm putting 4x plus 7 in both places. All right, so over to the side here, I'm going to work out this 4x plus 7. So if I square 4, so I get 16x squared, 4 times 7 times 2, so it's 28 times 2 is 56, so plus 56x. And then on the end, plus 49. Then I have to multiply all that by 3. So I'm multiplying all that by 3. So I end up getting 3 times 16, 48x squared plus, let's see, 150, 168, 168x plus, this is going to be 150, 147. Okay, so that's going to go there, and then I'll just finish it here. I have minus 2 times the rest of that, so minus 8x minus 14. So my final answer there is going to be 48x squared plus 160x, and then plus, it looks like 133. All right, over here, h of negative 1. So I would not find h of h. That would be like annoying. All right, but what I can do is I can find what h of negative 1 is. Like I can figure out the answer to this part and then plug it back into h again. All right, so h of negative 1. So I'm putting 3 negative 1 squared minus 2 times negative 1. So this gets me 3 times 1 in front, so 3 plus 2, so that gets me 5. Now I put 5 back into h, so because now I'm doing h of 5. All right, so put 5 in there, which gets me 3, 5 squared minus 2 times 5. So that'll be 25 times 3, so 75 minus 10, so 65. All right. Okay, moving on. Let's see. Graph this piecewise function. So 2x minus 1 for everything less than or equal to 2. So 2x minus 1 starts here, goes up 2 over 1 to there, less than or equal to 2. So it stops right there, and it's an equal bar. So I'm going to draw that from here back, and here's where it starts. All right, and x squared minus 2. So x squared minus 2 is going to be a parabola down 2, so it's going to start at negative 2. From there it goes right 1, up 1, right 2, up 1, 2, 3, 4. Ooh, I messed up on the answer key. Dang it. Oh well. So right 2, up 1, 2, 3, 4. Oh, there's a circle right there. All right, I thought it was up above that, so the answer key. And then from there, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's like right here. So it does come up here. So it's like a parabola. So I thought that those were together. I guess I didn't have my glasses on. So that is over a little bit. And there is a break, right? There is a discontinuity there. So there is a jump discontinuity at x equals 2, right? I was just using these other points here to try to graph my parabola, but they're not really part of it. Okay, all right, number 3, using the rational function pictured here, figure out these answers. So what's the domain? So the things that the domain is the x values. So it looks like it has a vertical asymptote right here, right? So this x value is not being touched, and also there is a hole right here that's not being touched. So x is not 2 or 5. So all real numbers where x is not equal to 2 or 5. All right, what's the equation of the vertical asymptote? Well, that would be x equals 2. Name the type of discontinuity. That is an infinite discontinuity. All right, name the type of discontinuity at 5. That's a hole, which is called a removable. All right, what is the equation of the horizontal asymptote? It's y equals 1. And the horizontal asymptote matches the end behavior. So those are both 1. All right, what occurred in the equation of this function for that whole to be there? Well, holes occur when you have something in the numerator and the denominator that cancel out. So there must have been an x minus 5 as a factor in both of those. And there could be, there's other things there, but this must have canceled out somehow. So explain that right here. There was a factor of x minus 5 in the numerator and the denominator that canceled out. All right, number 4. What's the domain of this? So you can draw it. It's a square root function. Move 3 to the right. So it looks like this and pops up. All right, so it's everything from 3 over. Or you could say to yourself, x minus 3 has to be greater than or equal to 0. So x is greater than or equal to 3. But I asked for an interval notation, so it would be from 3 to infinity. Bracket on the 3. All right, what's the domain of this function? So a rational function can't have 0 on the bottom, so x can't be negative 8. So basically, think of a number line. You got negative 8 here. You don't want that, but you do want these areas. So you want to come from negative infinity, stop at negative 8, parentheses, or you may continue on after negative 8 off to infinity. So that's how you would write everything except 8, right? So this is a parentheses right here. All right, at the bottom, how do you prove that two functions are inverses of each other? So you do f of g of x, assuming that your problems are f and g, and this should come out to x, and then you do the other way, g of f of x. So you should show that process of you plugging one into the other, and then vice versa, and you get x both times. All right, number 7. Given this function, how could you limit or restrict the domain so that the inverse would also be a function? So this is a parabola, right 2, down 1. So notice that this whole parabola, if I go ahead and graph this whole parabola, then what's going to happen is I am going to get something that fails the horizontal line test. All right, so how would I limit this? Well, I would just take off one side or the other, either the left side or the right side. I don't need it. All right, so I don't know. I'm going to choose to take off the left side. Okay, so I think I forget on the review sheet like which way I did it. I have it right. Oh no, I don't have it in front of me. I'll just take off the left side. So my domain, I'm going to say, is from 2 over. So from 2 off to infinity. My range, so basically what I'm doing here is I'm taking off this, I'm restricting this parabola to just this part. All right, my range is the same either way I do it. It's from negative 1 up, so negative 1 to infinity. Okay, so now I graphed my new g of x. I already have that here because I was already thinking with it. And graph my inverse. So my inverse is going to be, I can just use the points. 2, negative 1 is now negative 1, 2. All right, 4, 3 is now 3, 4. And the other point was at 5, 8, so I'll do 8, 5. And when I'm done, I should get a nice pretty picture, and that pretty picture should look like it's symmetrical over the line y equals x. All right, you don't have to draw that. All right, for number 8, given this function below, we are going to find the domain and range and everything, and then we're going to find the inverse. Okay, so this is a square root function, moved up 7. So it starts up here at 7, and nothing else happens to it. It just like pops up like that. So this is the point 0, 7, right? So from there I can tell the domain is from 0 over. Or I could have said to myself, hey, I want all the x's to be greater than or equal to 0. That's an infinity symbol, by the way. All right, and then the range is from 7 up. So 7 up to infinity. Now, you're supposed to know that when you do the inverse, you are reversing the domain and range. So this becomes 7 to infinity. And this one down here becomes 0 to infinity. Okay, find me the inverse. Well, I'm going to go back here. This is y equals, so I'm going to make it x equals radical y plus 7. So take away 7. And then I'm going to go ahead and square both sides. So my inverse, and I already, look at that, I already typed everything for you, is just x minus 7 squared. So x minus 7 squared is your inverse. That's a notation for the inverse right there. All right, number 9, let's just practice using some pictures. So remember, f minus g of 2 is the same thing as saying f of 2 minus g of 2. All right, so we just find those answers. F of 2, the blue one is f, so f of 2 is 2. G of 2 is right here. So 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. Yeah. So 2 minus 6 is negative 4. All right, over here, I'm just calculating, doing division. F of negative 2 divided by G of 0. So F of negative 2 is negative 2. G of 0 is right here, so that would be 1, 2, 3, 4. So my answer is negative 1/2. Now here, this is F of G of 1, so F of G of 1. So G of 1, so G of 1 would be right here, so that's 1, 2, 3, 4, 5. So that means that I have F of 5 to do. And we look at the graph, F of 5 is right here, and the answer is 5. Alrighty, so if you have a continuous function, so important that the word continuous was mentioned. No breaks, no holes, nothing going on weird. All right, and so let's draw this out. You know that f of 4 is 10, so 1, 2, 3, 4 is up here at 10, so you have a point there. And f of 5 is negative 3, so when I go to 5, it jumps down to negative 3. All right, so what you're supposed to gather right there is that if you were having a continuous function, your function has to go from here to here, right? And it's continuous. So the graph is discontinuous. Well, no, it says that the graph is continuous because the whole thing is continuous. There is an x-intercept between 4 and 5. That seems pretty likely because look right there, I had to go through the x-axis. All right, the point 410 is a maximum point. I mean, it might be, but you don't know for sure. I mean, it could be that this function, like, I don't know, just like came up like this and whatever. Like that doesn't have to be a maximum point. I mean, it might be, but we don't know that for sure. And none of the above is nope. We're going to go with letter B. All right, parent functions. So these are the parent functions that you practiced in class and we've been talking about for all this time. I got a paper I gave you, that cardstock that I gave you. Which ones have vertical asymptotes? So your vertical asymptotes are going to be your log function and also your rational functions. They have vertical asymptotes. Which ones have horizontal? Well, again, your rational functions, they have both. And horizontal asymptotes are also in your exponential. And which have both? Well, rational functions. Okay, so know how to pick apart which equation is which. You don't have to necessarily, like for the exponential and the log functions, you don't have to tell me what the asymptotes are yet necessarily, but you have to know like which is which. All right, like logs have verticals and exponentials have horizontals. And then rationals you should be pretty good at because like we've been doing those all chapter. All right, that is it. I'll see you in class. Bye-bye.